Alright, in this video I'm going to discuss phase changes and temperature changes, and hopefully you've seen a diagram that looks like this one before in your chemistry class, and if you haven't, or maybe you've forgotten, I would write this across the top, that this is called a phase change diagram. This is a phase change diagram. Okay, and it's very important to know what this diagram means. This diagram is very specific. It has a very characteristic shape that is the same in every diagram. It always has temperature on the y-axis and heat energy on the x-axis. Again, it always has this characteristic shape with 3 areas that are increasing in temperature, 2 areas that are flat. The only thing that will change is that for each particular substance, and depending on the amount of the substance that you have, these numbers will change, the temperature will change, and the thermal energy numbers will change. And this says that this phase change diagram is for water. We know that because this happens to be the freezing point, this happens to be the boiling point, and we know that those two are 0 and 100 for water. Right? So I want to go through this list of questions to help us to remember what the phase change diagram represents. The first question says, label the diagram with the following terms: vaporization, melting, freezing, and condensation. Hopefully you remember that these are all phase changes and we need to know where they go. Well, let's define them first. Vaporization is when you take a liquid and you change it into the gas state. Okay. And the opposite of that is actually condensation. Condensation is going the other way. It's taking a gas and changing it into a liquid. Okay, so those two are the same phase change, they just go in opposite directions. Melting is when you take a solid and you change it to a liquid, and the opposite of melting is freezing. It's changing a liquid into a solid. So these two are the same, they're just going in opposite directions, and these two are the same but going in opposite directions. Alright, so let's consider what's going on. Hopefully you remember that, you know what, maybe we should do this. Maybe we should answer number 2 and 3 first before we answer number 1, because we need to know what phases are going on. Hopefully you remember at number 1 on the diagram, you remember that you have a solid present. There is nothing but solid in number 1. There's no liquid, there's no gas, only solid. Right? So let's go ahead and go on up the list, and number 3 addresses number 4, but I want to know what all of these are. At number 2, hopefully you remember, is the phase change area, and during the phase change you have both solid and liquid for this particular portion. Both solid and liquid. In number 3 there is only liquid present. In number 4 this is the phase change from the liquid to a gas, so in number 4 you have both liquid and gas, kind of like a bad night at Taco Bell. That was a joke in case you couldn't catch it. And in number 5 there is only the gas state. Alright, so now that we know what phases are present at these places, let's look at each of these terms. Vaporization takes us from liquid to gas, and so vaporization is going to go right here. And on vaporization, I'm going to draw an arrow that goes to the right. The reason I'm doing that is because vaporization, moving from a liquid to a gas, the gas is a higher energy state. And so in order to vaporize a substance, we have to add energy. In other words, energy is increasing. It's going to the right. And at the same place, I'm going to have condensation. Condensation is the same process, but it's the energy release version of the process. And not going from liquid to gas, we're going from gas to liquid. Liquid's a lower energy state, so you have to get rid of energy to make water condense, right? To change it to a liquid. Melting and freezing is what's left. Hopefully you realize that those are the other 2 phase change states. Melting I'm going to write up here, M-E-L-T-I-N-G, and melting will go to the right because that's changing into a liquid, which is a higher energy state. We have to add energy. Energy increases. And freezing is in the same place but going to the left. Same phase change process, but you're taking away energy as opposed to adding it. All right, so those are your phase changes. You might want to write the answer to 4 would be liquid and gas. Phase is present at number 4. Question number 4 is very interesting, and I want you to read number 4. Perhaps stop the video for a minute and think about what your answer would be. Can you add thermal energy to an object without increasing its temperature? Look at the graph, stop the video, come up with an answer. Alright, I hope the answer you've come up with is yes, that you can add thermal energy without increasing its temperature. And you'll notice on the graph that there are areas where the temperature does not change. 1, 3, and 5, there is a temperature change, right? But you'll notice at number 2 and number 4, energy is being added, but the temperature is staying constant. So it is possible, yes, you can add thermal energy to an object without increasing its temperature. And the explanation would be is that at a phase change, there is no temperature change. At a phase change, there is no temperature change. And the question is why? It's an interesting thing, and you may not even believe me. You may not believe, oh, wait a second, Mr. Valls. If I'm adding heat to this substance right here, say you have a beaker of ice, and you bring it out in the classroom, we put it on a hot plate, we begin to heat the thing up. Pretty obvious to see that it's going to melt. And the question is, while it's melting, what will be the temperature? And you can go home and do this experiment, but be safe about it. If you have a cup of water, set it out on the counter and allow it to melt over time. And go take the temperature every once in a while. And you'll see that if that glass of ice and water is in thermal equilibrium, the temperature is going to be 0. Even though temperature is being added, or heat energy is being added rather, the temperature is not going to change. And that brings us back to this point of the fact that temperature and heat energy are not the same thing. Temperature is not a measure of heat energy, clearly, because here and here energy is being added, energy is increasing, but we're not changing the temperature. And here's the reason why. On this graph, there are 2 things that can change. 2 things delta can change. 2 things are changing. Only one of those 2 can change at any one time. You are either changing temperature, which is true at number 1, number 3, and number 5, or you are changing state or phase. And if you are changing phase, you cannot be changing temperature. And if you're changing temperature, you cannot be changing phase. They're mutually exclusive. They don't happen at the same time. And here's the reason. When you add thermal energy, the law of conservation of energy says that energy can't be created or destroyed. So it's got to go somewhere. And it goes to one of these 2 places. Either the energy goes to changing the temperature, which means the energy will go into directly increasing the speed of the molecules. The kinetic energy of the molecules is going to increase. So the energy can go there. Or at a phase change place like this, the energy doesn't go into increasing the speed of the molecules. The energy rather at a phase change goes into breaking the molecular bonds, because if you notice or remember from your previous science classes that ice is set up in a very particular crystalline structure that may look something like this, and there are lots of very strong molecular bonds that are existing in between all of these molecules. And it takes quite a bit of energy to break those bonds and reform a new molecular structure of the next phase. For instance, to go from solid to liquid. That takes some energy. So the energy that you put into a substance either goes to breaking these bonds, which means it cannot go into increasing the kinetic energy of the molecules, or it goes into increasing the kinetic energy of the molecules, which increases the temperature. Therefore, it cannot go into changing the molecular structure of the substance. So this is the main thing that I want you to know with this graph, is that on this graph, one of 2 things are changing at any one time. Either the temperature changing or the phase is changing.